Hey everyone, and welcome to this explainer. Today, we are unpacking the incredibly high-stakes world of web traffic security. Now, when we talk about protecting web apps, it's really easy to picture a web application firewall, or WAF, as this simple, impenetrable brick wall sitting right in front of a server. But honestly, that couldn't be further from the truth. Instead, I want you to look at the WAF as a gauntlet. It's the sequential, highly optimized, multi-layered filtration system. Every single web request has to run this gauntlet, and today we're going to map out exactly what that journey looks like, tracing it from the very edge all the way down to the back end.
Okay, let's dive into this architectural blueprint. We'll be covering entering the WAF gauntlet, the fast outer defenses, deep inspection and signatures, custom rules and APIs, and finally, the defense in-depth architecture.
Section 1. Entering the WAF Gauntlet, the architecture of web filtration.
To truly grasp how a WAF operates, we basically have to follow a single web request as it tries to reach your server. It's a journey, and a request has to survive these three major stages sequentially. It starts at step 1, the outer rim, which handles IPs, rate limits, and reputation. If it manages to survive that, it moves into step 2, deep inspection, looking for attack groups and nasty payloads. And finally, it hits step 3, the API armor and custom rules. This entire sequence is specifically designed to separate the malicious attacks from your legitimate traffic and to do it as efficiently as computationally possible.
Let's look at the very first layer it hits, Section 2, the fast outer defenses. Cheap, fast, and first.
Think of this layer as the bouncers at the door. IP and geo controls form this outermost defense, and decisions here are based purely on where a request is coming from. By using an IP block list or a geo-IP database to pinpoint the country of origin, the WAF actually saves vital CPU resources. Why? Well, because this check is extremely cheap. There is absolutely no packet inspection happening here at all. No regex parsing, no payload analysis, nothing. If an IP is on a block list or comes from a sanctioned region, boom, they get an immediate 403 drop, or even a TCP level drop, before any expensive inspections occur. The bad actors are simply turned away at the door.
Now, what's really interesting about this is what happens if the request actually makes it past that location check. It hits rate controls, which prevent volumetric abuse like DDoS attacks or scraping. But we have to choose how we measure time here. On one hand, we have sliding windows calculating the last n seconds dynamically. This is highly accurate for stopping distributed attacks, but it's computationally expensive. On the other hand, we have fixed windows, which just reset purely on the minute or hour boundary. If you rate limit your login endpoint using sliding windows, you can brilliantly stop those slow password spraying attacks, where an attacker tries one password every few minutes, even if each individual attempt looks perfectly legitimate. Next up in the outer defenses is client reputation. Instead of you having to manually update block lists, this uses a live threat intelligence feed baked right into the WAF. Every single IP gets a score. A score over 25, you might just log and monitor that. Over 50, you're going to want to rate limit them aggressively. But if that score crosses 75, you block them outright. And these scores are built from known botnets, Tor exit nodes, and data center IPs because, let's be real, actual human users rarely browse the web directly from an AWS or Azure server. This is incredibly powerful. It protects your application from known bad actors like Shodan scanners before you've ever even seen them attack your specific site.
Let's move to the next layer and see how this builds. Section 3. Deep inspection and signatures. The heavy lifting.
Okay, so if a request passes those fast outer defenses, it enters the classic WAF layer. This is where the heavy lifting really happens through deep packet and payload inspection. This is the computationally expensive part where precise regex patterns and heuristics catch those deep payload attacks. For SQL injection, it's looking for patterns like union select or drop table. For cross-site scripting, it's scanning for unauthorized script tags or encoded payloads. It even catches remote code execution attempts by hunting for shell metacharacters, and it blocks known scanning tools by matching their specific user agent strings. This layer is thorough. It examines the full HTTP request, the URL path, the body, the headers, the whole shebang.
But how does the system decide when to actually pull the trigger and block the request? Well, it uses anomaly scores. As the WAF scans through those thousands of regex patterns, every single match increments an anomaly score. When the total score crosses a specific threshold, the request is blocked. And what dictates that threshold? Your paranoia level. A higher paranoia level is going to catch far more subtle attacks for sure, but it inherently raises your false positive rates. This means you have to carefully tune this aggression level on a per-application basis, just to ensure you aren't accidentally blocking legitimate users who happen to trigger a minor heuristic rule.
Moving deeper into the gauntlet now. Section 4. Custom rules and APIs. Tailoring your armor.
All right, this is where the pre-built off-the-shelf rules end and your highly specific, granular application-level logic begins. Custom rules let you build logic based on almost anything. You can match on HTTP components like headers and cookies, time of day, or even J3 TLS fingerprints, which actually identify the specific browser engine being used right at the encryption layer. And keep in mind, rule processing is strictly ordered. The first matching rule wins. As an example, you could write a custom rule to drop any request where the user agent is totally empty, because legitimate browsers basically never omit that. Or you could write a rule restricting access to your /admin path strictly to your physical office subnet. And this brilliantly illustrates how we protect structured data, specifically APIs. Traditional WAF rules often totally miss API-specific threats. But with API constraints, you can actually upload an OpenAPI or Swagger specification directly to the WAF. The WAF then uses this as a rigid, uncompromising schema. It enforces allowable methods, meaning if an endpoint is only supposed to get GET requests, a POST request is immediately killed. It checks parameter sizes to prevent buffer overflows and blocks undeclared parameters entirely. This structural awareness stops mass assignment attacks and type confusion bugs instantly, completely tailoring the WAF's armor to your specific code.
We have finally reached the climax of our journey. Section 5, Defense in Depth Architecture, bringing it all together.
Listen, if you take away nothing else from this explainer today, remember this: defense in depth. It's a layered security model where each control sequentially compensates for the weaknesses of the others, meaning no single layer is relied upon alone. This is the absolute core philosophy of a modern WAF. If an attacker manages to somehow bypass one layer, the next one is waiting right there for them. It is a completely interconnected ecosystem of security.
So the crucial point here is how this entire architectural map creates massive operational efficiency. Just look at how this flows sequentially. In step 1, a known bad IP from a botnet hits that reputation layer and is dropped immediately. That saves massive amounts of CPU time because it never even triggers those expensive signature checks we talked about. In step 2, a brute force attack triggers the rate limits and gets blocked, meaning it never reaches the API schema validation layer. Finally, in step 3, only the clean, surviving traffic hits your custom rules for that final, precise validation. Blocking things at an earlier, cheaper layer is exactly what prevents the request from bogging down the expensive, heavy lifting layers.
We've seen how the gauntlet operates, catching everything from bad IPs to complex SQL injections using defense in depth. But I want to leave you with this final provocative thought. Your WAF handles the known threats perfectly right out of the box. But what custom rules will you build for the unknown? Because true security isn't just turning on a firewall, it's adapting it to the totally unique vulnerabilities of your own application. Thank you so much for joining me for this explainer. I really hope this changes how you view web traffic defense, and I'll catch you in the next one.